Hey, what's up? This is Anupam. Welcome back. This is the second tutorial on the video tutorial series on UART in STM32F4 Discovery Board. You can check out my website www.logicvoltage.com. You can watch many other tutorials at the website also. You can even check out the video store at the website. It has some good tutorial series there with a very attractive price. Lot of people are buying it. You can also get them and learn some very awesome things about embedded programming. You can get in touch with me also in case of any query. Just go to contact us page and fill up the form and I will reply. You can check out the forum also. For any tutorial related queries or any technical questions, you can just register yourself on the website and then create a new topic on a forum and write your questions and doubts. And I will reply back there so that other people can also see the comments and what discussion is going on. Please make some donations so that we can continue to create free tutorials for you. You are welcome to choose any amount as you like for donation. We will be highly appreciated. You can also support us by subscribing my YouTube channel. Thanks. Okay, in the previous tutorial, we have learned about UART communication protocol, how UART communication works, and then we have built a circuit using two discovery boards. This was the circuit that we have built in the previous tutorial. We have two discovery boards here. First is STM32F4 discovery board, in which we have ARM Cortex M4 STM32F407VG microcontroller. And then we have a second board, STM32VL discovery board, in which we have ARM Cortex M3 STM32F100RB microcontroller. We have three switch buttons here connected to first discovery board, and then we have four LEDs connected to second discovery board. Now in the first board, that's STM32F4 discovery board, we will write a program in such a way that when we press a switch, it will transmit something using UART protocol to the second discovery board. Now if we press first switch, it will send A character. If we press second switch, it will send B character. If we press third switch, it will send C character. Now in the second discovery board, that's STM32VL discovery board, we will write a program in such a way that it will keep looking for character sent. Whatever it got anything, it will check. So if received character is A, then it will light up the first LED for 2 seconds. If the received character is B, then it will light up the LED for 2 seconds. And if the received character is C, then it will light up the third LED for 2 seconds. And in case the received character is none of these A, B and C, which can only happen in case of transmission errors, then the fourth LED will light up for 2 seconds. Now you can see that first discovery board STM32F4 is acting as a transmitter here, and the second discovery board STM32VL is acting as a receiver here. Okay, as I already said in the previous tutorial that we have to write programs separately for each discovery board. So let's first write the program for first board, that's STM32F4 discovery board. Okay, let's start writing the program which will act as a transmitter here. Let's create a new project. Let's name it STM32F4 transmit. Okay, so now our project is created. Let's first delete these comments. Okay, delete these unnecessary statements also, we don't need them. Okay, let's correct the clock settings. If you don't know why I just changed the clock settings here, then check out my previous tutorials on my YouTube channel. You will then understand everything. Okay, so now first we have to initialize all the pins on which the switch buttons are connected and put them in input mode so they can detect for switch press. So let's do that. Okay, so now we have configured the 3 pins in input push-pull mode. Now we have to configure interrupts on these pins where our 3 switches are connected so that whenever these switches are being pressed, an interrupt generates. Let's do that. Okay, so we have configured and initialized the external interrupt line 1 and 2 and 3 because our switches are connected to PA1, PA2 and PA3. We have configured all these three lines in interrupt rising mode. Hence, whenever someone presses any of the switch, the voltage will go from 0 to high volt on that switch and on the microcontroller pin on that switch is connected, and hence an interrupt will occur. If you are new to interrupts and this is the first time you are writing code for interrupt configuration and initialization, then I would suggest you to go to website www.logicvoltage.com and check out the tutorial series on interrupts of STM32F4 Discovery Board. On that tutorial series, you will learn about all the concepts of interrupts, how interrupts work, and there was a cool program also written so that you can learn and how practically the interrupts work. And in that series, you will also find a very awesome product of motion sensor also. After you are comfortable on interrupts, only then you should continue this tutorial. Okay, so now external interrupt lines are initialized. Next is we need to configure and initialize NVIC also for these interrupts. Let's do that. Okay, so now we have configured and initialized the NVIC also for these external interrupt lines. Again, if you do not understand how and why we are initialized the NVIC, then please check out the interrupt series on www.logicvoltage.com. Okay, so now our pins configured and interrupt are also configured and initialized. Next is we have to write the interrupt service routine for each interrupt so that whenever the switch will be pressed, an interrupt will generate and corresponding service routine executes. So let's write the service routines. Let's first write the service routine for external interrupt line 1. Okay, we haven't written any code here in this ISR. We will have to write the code to send a character here using the UART communication. We will write that later. Okay, next write the service routine for external interrupt line 2. Same here, except when this ISR executes, it should send B character using the UART communication. Now next is write the service routine for external interrupt line 3. Hence, when the third switch is pressed, this ISR will get executed and it should send the C character. Okay, so now interrupts are initialized and we have written the interrupt service routines also. Although they are still incomplete as we still haven't written any code for sending characters in these routines. We will do that in some time later, because before that we need to understand few things first. Okay, so now before we write any code, we have to first decide which UART to initialize and use here. I know you must be wondering how many we have then. Let's open the technical data sheet of the microcontroller. If you are seeing this technical sheet for the first time or you are not sure what is this, then I would suggest you to please go through my first or maybe second tutorial in my YouTube channel. You can even check out the website www.logicvoltage.com for this also. There you even know from where you can get this data sheet. Okay, I assume at this point that you already have an idea about what a data sheet is. So here I have opened the technical data sheet of the microcontroller present on the STM32F4 discovery board. Now let's go to page number 34. Okay, here you can see that we have a table. If you can see the left side here, we have USART names written one by one. Now, before going forward, I want to tell you one thing. If you remember in the previous tutorial, I mentioned about USART. Although we are learning UART communication here, but USART is not a different thing. Only main difference is a new clock line connected between transmitter and receiver. Rest is nearly same. Now here in the data sheet you can see that we have USART 1, USART 2, USART 3 and then UART 4, UART 5 and then USART 6. So that means we have total 4 USART and 2 UART peripherals in this microcontroller, and we can choose any in our tutorial. As we are going to do UART communication here, so we can use either UART 4 or UART 5, but we can use USART peripheral also to do UART communication. Actually, let's use USART in this peripheral in this tutorial. I would use USART to do UART communication so that you can see how configuring both is nearly same. Okay, so let's choose UART 3 to do UART communication. Okay, so now we have decided which USART or UART to use. Now next thing is we have to find out which microcontroller pins we can use as USART3 transmitter and which pins we can use as USART3 receiver. Let's find that. Now go to page number 45. You can see that a long table starts from here. This table is actually around 10 to 12 pages long. In this table, we have all the microcontroller pins listed, as well as each pin is connected to which peripheral. Now if you search for USART3 in this table, then you can see that we got many pins assigned to USART TX and USART RX and USART CK. We don't need CK pin because we will do UART communication here, and here we'll not use the clock line. CK means clock, but we need TX and RX pin. So let's choose PD8 and PD9 pin. PD8 is connected to USART3 TX and PD9 is connected to USART3 RX. So we will use these two pins for doing the UART communication. Okay, so now we have decided USART3 and then pins PD8 and PD9. So now we can start writing the code for initializing the USART3 peripheral. Let's get back to our program. Okay, now we have decided USART3 we will use for doing the UART communication, and we have PD8 pin for transmit and PD9 pin for receiving. Well, actually we would only be needed PD8 pin only for transmitting. As the STM32F4 discovery board, we only transmit A, B or C characters and we are not receiving anything here. So we need to configure only the transmitter pin here and not the receiver. So let's start configuring the USART3. So first is we need to put the transmit pin PD8 on alternate function mode. Till now we have seen many times where we have configured pins either in input or output mode, but this time we are using a microcontroller pin for a USART peripheral. So here we have to use alternate function mode. So let's start doing one by one. First, start the clock for the port D. Then put the PD8 in alternate function for UART3. Then let's configure and initialize the PD8 pin. Okay, so now our PD8 pin is configured and initialized. Now we can configure the USART3. As I said earlier also that we will actually do the UART communication, but we are using here USART peripheral because we can do UART communication using the USART peripheral also. So sometimes if I say USART, that will also means UART. Okay, so let's configure the USART3. First, we have to start the clock of USART3 peripheral. Now let's configure and initialize the USART3 peripheral. First, declare the USART structure. Okay, if you press Ctrl key on keyboard and left click on this, then you will be redirected to a USART header file. You can see that we have 6 parameters here whose value we need to set. Let's do one by one. In this, we are setting 9600 bps baud rate. I have already explained the baud rate in the previous tutorial. So we will use 9600 bps baud rate for our UART communication. Next is in this we are setting 8-bit data we will send in a single frame. We can even choose 9-bit also here, but let's keep it this way. Now next is in this we are setting one stop bit. In this we have 4 options to choose, as I already shown in the previous tutorial. So we are right now choosing one stop bit. Now next is in this we are configuring the parity bit. Actually, parity bit is a bit in which we can tell if the received frame is correct or not. I mean, this bit is used to check for transmission errors. You can go to online also and learn about this in details. Well, right now we do not need any parity, so let's keep it this way. Now next is in this we are setting that we will use only the transmitter of USART3. We can choose receiver only or even use both. But right now we are only using the transmitter part. Now next is In this, we setting that we do not want any hardware flow control. This setting is actually required if you need any control on the UART data transmission. You can go to reference manual and go to page number and read this section to understand how we can control flow of data transmission. Now next is here we are calling the function to initialize the USART3 peripheral, and then we have to enable the USART3 peripheral. Okay, so now our USART3 is properly configured and initialized, but we have still one thing remaining. We have just configured the USART3 but still not sending anything through the USART3 transmitter. So now we can do that in the interrupt service routines of the switches which we have left earlier. Let's do that. First, in the external interrupt line 1 ISR. So when this first switch is pressed, it should send character A. Let's write the code for sending that. Okay, so now these two lines will send the A character using the UART communication. The first line is sending the character, but we need next line also so that the character is sent and not kept in buffer by the microcontroller for later sending. Okay, you can see that I have written A here, but in the UART communication the bits are being sent, and we have configured our UART peripheral in such a way that it will have one start bit and then a data bit and then one stop bit. Hence, in a single frame we will be having total 10 bits. Now you must be wondering how A will be sent. Well, actually this A will be converted to ASCII binary, and which is 10000001, and hence our complete frame will look like this: 001 0000011. So you can see how we are sending the A character. Okay, so this ISR is now complete. Next is ISR for second switch. In this, it should send B character. Okay, then same for third ISR, it will send C character. Okay, so we have properly written the ISR for each interrupt of switch press. Okay, so now our program is complete and we can build this program and run it on the STM32F4 discovery board. So let's do that. Okay, we have run the program on the STM32F4 discovery board. But this is only half part. We have only programmed the transmitter, and that's STM32F4 discovery board. But our receiver, that's STM32VL discovery board, is still not programmed. So nothing you will see here happening right now. There is one more thing we haven't done yet. That's we haven't connected any wire from the first discovery board transmitter pin to second discovery board receiver pin. In the previous tutorial, we didn't know which pin we will use for transmitting and receiving. But now we do know that we will use PD8 pin from the first discovery board for transmitter. But we still didn't decided which pin we will use for receiver in the second discovery board. So let's right now keep it this way. In the next tutorial, when we have decided about the receiver pin, then we will connect a new wire here. Okay guys, in this tutorial we have configured the 3 switches and initialized the interrupts on them, and then initialize the USART3. So our transmitter is complete, and we now press any switch, it will transmit character either A or B or C as per which switch is pressed. So in the next tutorial we will write the program for the receiver board, and then we will run the whole program and do UART communication. Once again, this is Anupam from www.logicvoltage.com, and thanks for watching. Bye.